Hello everyone, welcome to LeetCode walkthrough series. Today we are going to solve valid triangle number problem. Let me start the timer. So, given an array of nums, return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle. So, they've given an input array called nums, of which the values represents the side lengths of a triangle for valid triangle. So we need to identify triplets values such that it makes a valid triangle. So we have to return at the end how many of such valid triangles are possible. So now for a triangle to be valid, we need to make sure for any triangle to be valid, we need to make sure the sum of the length of the two shorter sides must always be greater than the length of the longest side. So for this example, ABC triangle, if C is the longest side, we always have to make sure length of A plus length of B is always greater than length of C. Similarly, if B is the longest side, we have to make sure length of A plus length of C greater than length of B. And finally, if A is greater, bigger length, so we have to make sure B plus C is greater than A. So if these inequalities hold true, then we can say it's a valid triangle. There are two ways to solve this. One is brute force method. Uh, if we take 3 pointers here, C, left, right. So for this example, let me show you. Okay, let me add some values here. Okay. So for this problem, brute force method says for any outer loop value here, for example, if C is pointing at the start index and left is pointing at the second index and right is pointing at somewhere in between. So for every outer loop with C pointer, we need to make sure inner loops run n number of times. To get the triplets, outer loop C, for every outer loop C, we have to run n L inner loop n number of times and R inner loop n number of times. So that makes it a costly operation with the order of n cube time complexity. So the optimal approach for this problem is, first I will sort the nums array. By doing this, let me show you. Comma 2, comma 2, 3, 6, 4, 5, 6, 10. Okay. By doing this, we will definitely know that the last value will be the longest length. So I'll place pointer C here and pointer R at the penultimate index and pointer left at the first index. So this is my starting point, starting position of all the pointers. So what this makes is we can easily eliminate a lot number of inequality checks by doing this. Suppose nums of C plus nums of R is greater than nums of L. So here you can see if by adding the value of nums of R to the already longest value, it will obviously become the greater than nums of L. So similarly, nums of C plus nums of L is greater than nums of R. Yeah, again, if nums of the longest is nums of C, which is 10, and if we add something to that, it will be greater than nums of R value. So we can eliminate such type of inequality checks that which reduces the system load, the competition. So now how we approach the how we do this is, for every iteration, we will check the value of L and value of R is greater than value of C. So now 1 plus 6 is 7. It's not greater. If it is not greater, we will increment the pointer, left pointer, and that comes here. Now, so here, okay, R and C will be this position, and 6 plus 8 will that makes it 8. It is still less than 10, and L comes here, and still less than 10. L comes here, it's 9, still less than 10. L comes here and still less than 10. And when L is here, the summation value is 11, and we have a triplet here. So suppose if there are few more values here, like 7, 8, 9. Okay, I'm just taking an example. The greater values. Let me see. Say the R and C are pointing to the last indices. Okay, if there are some more values here, if the pointer L is pointing at the fifth index, the sixth index of value 5, we can say if this is a triplet, then the subsequent values along the path of left pointer will always be greater than C. So in that case, this makes it skip these many number of additional computations. So let me take the final result count of triplets as result count value. So we will add R minus L as the total count here. So that 1, 2, 3, 4, 5. So 5 triplets are found here in this single iteration. So when this is the case, we will once that is added, we'll decrement the R pointer, uh, and check the values for these combinations. So L will be here, and we will see once the R pointer is reduced, the algorithm comes here. Okay, R will be pointing at 7. I'm sorry, 8. So in this case, we will see if 5 plus 8 is greater than C. Yes. Again, we have a triplets count here. Then the result count is incremented, and then we can skip all these subsequent values again in the next iteration. So then R comes to the 7th value, and we will check 5 plus 7 is greater than C. Yes, it's greater. Then we'll skip these computations, and when R and L are side by side, we will break the loop and come out of it. And then in the next iteration, the C will be pointing to 9th value. So the L will point here, and then R comes to uh, previous value of C. Okay. In this case, again, for longest length 9, we will again find out the triplets similar to how we find out the triplets for longest value 10. So this goes on, and finally we will find the result count as number of triplets, and we return that value as the answer. Okay, so now let me code this solution. Firstly, let me sort the nums array and put the result count value 0. Now I will run the loop for C in range of array length -1. The starting index is the last value, and we will stop the cth value at last, but I mean the third index, because we have to leave at least two spaces for left and right pointers. So if I mention 1, it will stop at third index. If we iterate in reverse order, so I'll iterate in reverse order. So yeah, now we have the loop in place, and then we will check if uh, the longest side is sorry, okay, the right pointer is equal to c -1, and the left pointer is pointing in 0th index initially. Now if nums of mm, L plus nums of R, we are taking the addition of these two values. If they are greater than nums of C, the last value, then we will increment the result count. Result count is 1, and decrement the sorry, we will take right minus, I forgot to mention it fully. These are right and left pointers. Okay, right minus left as the total triplets value count. So we found the triplet value, and we will decrement the right pointer value. Instead of if, I forgot to. Okay, initialize inside the while loop here to take, but always make sure left pointer is lesser than right pointer, and then inside this while loop we have to check the inequality condition. Now in this case, yeah, we are sure the left and value of L and value of R are greater than C. That's why we found the triplets count. Therefore, we took the right pointer minus left pointer as the total number of triplets by skipping these values. Yeah. So the next condition is if L plus R, left pointer value plus right pointer value, is not greater than 10, then that is the case elif condition comes in. So in that case, okay, or that could be equal or lesser than um, the longest value. So we'll combine them and put them in else condition. So we'll implement the left pointer here. So yeah, we have the final value in the result count here, and we'll return that result count. So done. So the triplets count will be inside this one. So a result count value, we will return that value. Let me see this if it works. Okay, the solution works, and I'll submit it. Okay, the solution is successful. So coming to time complexity, the outer loop runs here, the outer loop with the C pointer runs in worst case a number of times, and for every outer loop the two pointers traverses a number of times, so the time complexity is order of n squared. And the space complexity, since it is happening, the competition is happening is in place, it is order of 1. There is no need of extra memory required. Yeah, that's all about it. Thanks for watching.